Machine learning can be used to generate music. In the case of Feynman Liang's research project, Bach Bot, the machine learning model is seeded with the music of famous composer Johann Sebastian Bach. The music that Bach Bot creates sounds remarkably similar to that of Bach, although it has been generated by an algorithm, not by a human. BachBot is a research project in computational creativity, and Feynman and I talk about what that means. We also discuss how BachBot uses Python's machine learning tools to build a long short-term memory model. We also talk about artificial intelligence, music, his approach to the research project. This is a really enjoyable conversation because I'm very interested in music as well as machine learning. Before we get to this episode, a few quick announcements. If you're interested in advertising on Software Engineering Daily, send me an email, jeff@softwareengineeringdaily.com. There are more than 14,000 engineers that listen to Software Engineering Daily on a regular basis, so it's a great place to get your product out into the ears of developers or to advertise available jobs that you might have at your company. Also, if you're an engineer that's looking for an open source project to work on, check out Software Daily at softwaredaily.com. This is an open source news and information site about software. It's being led by Jeff Tribble, a member of the Software Engineering Daily community. You can also check out softwareengineeringdaily.com, which is the website for this podcast. You can find links to the Slack channel, my Twitter account, my email. You can find a link to sign up for our newsletter, Software Weekly. And with that, let's get to today's episode. Continuous integration is so useful that I've started using it on my own personal projects. SnapCI from Thoughtworks has the fastest setup I've ever seen. I registered for SnapCI with my GitHub account, and after a few clicks, I had continuous integration pipelines set up for a Node.js application and a Rails application that were just sitting on my GitHub account. And I don't want my users to experience breaking changes, so I want to run a large suite of tests for my application every time I push a change. And SnapCI will run those tests quickly, in parallel, on a worker that SnapCI spins up and takes care of for me. Whether you have personal projects like me, or you work at a company that is looking for the perfect tool to improve the deployment process, go to snap.ci/softwareengineeringdaily. SnapCI embodies the lessons that Thoughtworks has learned from 20 years of software deployment, the same lessons that have been written about by Martin Fowler and Jez Humble. Check it out at snap.ci/softwareengineeringdaily. It would support Software Engineering Daily, and you would get to check out continuous deployment. snap.ci/softwareengineeringdaily. Thanks for listening. Feynman Liang is the creator of Bach Bot, a research project on computational creativity and music. Feynman, welcome to Software Engineering Daily.
Thank you.
What is Bach Bot?
Bach Bot is an artificial intelligence that can compose music to the style of Bach.
And why did you start this project?
Well, the project was actually proposed to me by Microsoft Research Cambridge as a potential MPhil project, and I thought it was very interesting, and so I volunteered for it about 6 months ago.
Do you have a background in music?
Yeah. I played piano for about 5 years, and after I stopped playing piano, I played guitar, and that's when I really became interested in music theory and how chord progressions worked and that kind of stuff.
So why did Microsoft come to you with this idea?
So Microsoft is a sponsor for the MPhil that I'm in at Cambridge. And so as an industry sponsor, they were able to propose a project which students, if they were interested in, could participate in.
I see. So why was Bach the selection of musician for this project?
Well, the project we actually toyed with a variety of composers, but we found that the Bach chorale corpus was the most readily available and had been the most thoroughly studied with prior work to compare against.
I see. So this is like the Arabidopsis of biology or the image net of machine learning image processing.
Yeah, you could, of sorts, yeah.
Okay. So BachBot is a research project on, quote, computational creativity. What does that mean?
Computational creativity? Well, I think it means a lot of different things to different people. To me, it's sort of the trying to understand creativity and whether it's actually algorithmic or not. I think BachBot itself is inherently a probabilistic system where we use randomness in kind of the same, in a controlled manner, similar to how artists can deviate from the style a little bit, but maintain consistency elsewhere.
Okay, so do you have a definition for what you see as creativity, or do you see it more of this abstraction of mechanical and stochastic processes?
Well, so yeah, I mean, I don't actually have a definition for creativity, nor do I have a definition for what Bach actually means to different people. I think there's a lot of subjectiveness to how we interpret art and what we think is creative and what isn't. And so that's kind of why I made BachBot this discriminative test where it was not just, oh, I think it sounds like Bach, but rather, hey, let's see, what do people in the world think this sounds like?
What's the difference between computational creativity and what a computer is normally doing?
That's a tough one. Well, so a computer normally you want it to operate and execute a deterministic set of instructions. I mean, stochastic behavior. I mean, we have words for this, like Heisenberg. It's not fun. We want our computations to be deterministic, very well understood. In contrast, when we want to generate music, well, if we just generate something that's very algorithmic and deterministic, then to the user, it doesn't sound very original. It sounds like a loop or a lot like the fractal music that we've seen back in the days. So to really generate something that humans will judge as creative and could be actually human in some sense requires very, very well-constrained breaking of rules and adhering to rules elsewhere.
It seems like computer science is often this back and forth between grappling with stochastic processes and grappling with highly organized processes. Like, even if you just look at the level of the transistor, we have this binary 1 or 0 idea that's not actually the case. It's in actuality, it's a range of voltages that is, kind of non-deterministic. But if the voltage falls within that range, then it's a 1 or it's a 0. So we build on top of that notion. We can build deterministic things on top of that notion. But then, of course, you talk about the systems that we're building today, and they feel somewhat more non-deterministic. You get on Facebook and you don't know what kind of content is going to be served to you. So there is this back and forth notion between determinism and non-determinism in computer science. I think that's really interesting that you pointed out this idea of like kind of going digital, latching to like a 0 or a 1 rather than the analog signals. In some sense, the BachBot model, it uses something called long short-term memory, where the notion of memory, like how it stores data, is actually going backwards towards the analog world where we have real numbers rather than zeros and ones. Right. Okay. So I want to get into long short-term memory a little bit later, but talking a little more at the top level, is there something about human beings that makes it easier for us to do things that are creative in contrast to computer systems?
Is there something special about Qian? Well, I'd like to think there is. I don't know is the real answer. I sure do at the moment feel that I'm much more creative than a computer program. But I guess this is the question that AI researchers are directly or indirectly researching.
Well, so from the point of view of music, music composition is this task that requires both creativity and an understanding of music theory. Music theory, is this, for people who don't know much about music theory, how well defined are the rules of music theory? Is it set in stone? Is it more of a like touchy-feely sort of thing?
Well, it depends on the particular genre of music we're talking about. For the Baroque style of music that Bach was composing, at the time he was actually quite revolutionary, breaking significantly many of rules of his predecessors. But now, as we return as scholars and look at Bach's work, we actually identify some very, very strict rules that were always adhered to, such as no parallel fifths or parallel octaves. So there's actually quite a few rules that you have to abide by in order to actually have something that a music theorist would say is a convincing harmonization of a chorale or composition of a chorale.
Can these rules be interpreted by a computer program?
So that kind of hints at this conflict in a lot of automatic composition systems, which is between symbolic rule-based systems versus connectionist systems where we just have neural models. And BachBot is of the connectionist camp, so I can't tell you directly what the rules BachBot learned are, but I can show you pictures of, its neurons over time, and we can try to interpret the activity.
Okay, so this is one of the prevalent features of some of the machine learning systems that are being built today, where you have a machine learning system that seems to do its job, but you may or may not know why or how it is doing its job. Would you say that's accurate?
Yeah, it's we have tests where we apply certain kinds of stimuli, and we try to understand what are the firing patterns of specific neurons. And yeah, we actually found some very interesting like edge detectors and feature detectors, but yeah, to a large extent, I think the way we interpret neural network models right now, it's very difficult to understand what's going on inside.
So let's start to get into that. Give me a high-level technical explanation for how Bach Bot works and what it does.
So Bach Bot is a sequence probability model. I think in research we call it a language model. The idea is quite simple. It basically consumes a sequence of characters. So say like the note A and then the note C and then the note E. And then it predicts what the next character after seeing those three are. And then it uses that prediction, feeds it back to itself, and kind of just recurs and goes forwards over time.
Okay, so maybe is it like a state transition model, sort of? Is that how things are modeled in BachBot world?
Exactly, yeah. It's a state transition model where you just consume token after token after token.
So let's talk through some basics of recurrent neural networks, because this is how BachBot works internally. We don't need to go into too much detail because I've tried to do this before. It's tough to explain on a podcast, particularly because I'm not an expert in recurrent neural networks. What is a recurrent neural network?
The idea of a recurrent neural network is that you share the same network over and over and over again over time. So it's kind of this idea that the dynamics of my system don't change with respect to time. And so I'm just going to reapply the neural network over and over. And the way it works is you start out with some initial state, have you will. You can define it arbitrarily. In BachBot, it's just a big vector of zeros. And then you march through a sequence of symbols. And the symbols are whether a C was played, whether an E was played, whether there's a fermata or not. We tokenize music into these sequences, and then as the neural network walks through the sequence, the hidden state gets updated.
The hidden state. What is the hidden state?
It's the thing that you give it an initial state, like the vector of all zeros, and then that's kind of just protected inside of a memory cell. As the model goes and consumes input sequences, it does some matrix multiplications to go and update the hidden state.
Right. So recurrent neural networks are often useful for recognizing patterns in data sequences like text or genomics or handwriting or stock tickers. What are the commonalities between these different fields that make recurrent neural networks useful for these?
Well, the defining characteristic is that you have sequences and they can be of variable length. So traditional neural networks, they actually have a very strict assumption where the dimensionality of the input is fixed. And that's relaxed with recurrent neural networks. So when you have a sentence that could be 2 characters long, or it could be, I don't know, a couple paragraphs, you can process it with the same model.
Okay, you mentioned that the general structure of your network is not changing over time. So what is changing in a recurrent neural network? Where is the learning occurring?
So there's 2 phases of learning. There's the learning where we actually learn the network dynamics, and then there's the learning as it predicts on a particular sequence. Which learning are, like, should I talk about both?
Can you go through both? Yeah, please.
Okay. So the first kind of learning is the model dynamics learning. So in this situation, we have input sequences of tokens that Bach actually composed, and we train the network to we train the network to figure out how to update its hidden state in order to and make predictions on the next note of a sequence given what it's seen so far. And so that kind of lets you learn a model such that the hidden states get updated in a way that the model is able to use that hidden state to predict the next note in a good way. So hopefully the hidden state learns some features relevant for predicting the next note. And so in that case, we're actually not we're just learning the weight matrices on the recurrent neural network, such as how does the hidden state transit or change as we go forwards in time, and if I see this kind of input, what should I read and write into the hidden state? And so once that first learning of the network dynamics is done, the second phase of learning is actually when it's during runtime, during evaluation. And that's the case where we're given a sequence and we're asked, okay, find a harmony for this sequence, or we're told to just randomly start composing. And in this kind of learning, no parameters are actually being changed, but the hidden state is being read from and written to at each point in time.
Okay. So now we've talked about recurrent neural networks. What about long short-term memory? What is that?
Long short-term memory is just a special kind of recurrent neural network where the hidden state that I've been talking so much about has 3 gates around it. It has an input gate, a forget gate, and an output gate.
Can you describe how those things work?
Yeah, so the hidden state, so every hidden state is a function of the previous hidden state and the current input. And so the forget gate sits between the previous hidden state and the current hidden state. And you can kind of think of it as how much are we going to just kind of reset the memory at these different locations. The input gate modulates how much the input affects the memory. So we can interpret that as a write operation to the hidden state. And the output gate is gating how that hidden state goes and makes predictions about the next note. And so we can kind of view that as reading the hidden state.
So what are the kinds of problem domains that an LSTM, the long short-term memory version of a recurrent neural network, what kinds of problem domains are they useful for solving?
Well, LSTMs are good because they can learn long-term dependencies. I think they were actually invented in order to solve a problem known as the vanishing gradient problem, where recurrent neural networks take really, really long to learn because because the signals you need to learn vanish at exponential rates. Since then, we've seen that there's a lot of papers that show LSTMs can learn some very interesting concepts, such as learning to count, learning to fire oscillations at very periodic intervals. We've even had LSTMs learn to parse, so we can feed it the source code of a computer program, and we can train it to execute these instructions and output the result of that computation. There's a lot of excitement in them, and I think they're one of the most widely used recurrent neural network memory cells out there.
So can you give an example of a feature of maybe the music data set that the LSTM would be more effective at recognizing, in contrast to a regular recurrent neural network?
The LSTM is good at recognizing long-term dependencies. And so I'm actually in my thesis right now, which I'll post to BachBot once I complete. I've actually identified a neuron which is capable of identifying motifs regardless of how farly spaced in time. And so this kind of demonstrates that these certain neurons in the LSTM are able to learn features that span over the course of maybe 8 to 12 bars of music, which is, in my text encoding, over oh gosh, I don't know, 16 times 4 times 4, like, yeah, over about like 300 text. I can't do the math in my head. Sorry.
So that's pretty impressive. What is, how long does the motif have to be?
There's all kinds of motifs. We found chords or certain neurons that are specific to individual chords, as well as some progressions. When I did some Roman numeral analysis of the chord progressions, it's a way of kind of putting equivalence classes on chords and kind of classifying them. I found that the kind of chord progressions that certain neurons fired for corresponded to well-known cadences such as the perfect cadence and plagal cadence.
Wow, interesting. So let's talk more about how Bach Bot works in terms of actual software that we're using or that you use to build it.
Sure.
So what format are the input song files in?
They're actually taken from a corpus provided by Music21, which is a Python library for dealing with music data. But if you don't want to use Music21, the Bach Bot chorales or the Bach chorales are available all over the internet as encoded in MIDI, Kern, Music XML, most of the most popular formats.
So what are the other tools that are used with Bach Bot? Like you ingest those song files using the Python library. I think you said it's called Song21?
Music21.
Music21, yeah. Okay, so then what are the other tools that you use in Bach Bot?
Well, the GitHub repo, I built a really nice command line interface to go and run all my experiments and group all my scripts. And I did it using a Python library called Click, which is just really good for command line parsing and like options and arguments and that kind of stuff. Probably where all the machine learning comes in is this library called TorchRNN. So Torch 7 is a machine learning, it's a matrix algebra framework. It lets you do matrix computations on the GPU, and it's written for Lua, and it's really popular for machine learning, and TorchRNN is one of the fastest implementations of long short-term memory that I've found benchmarked on the internet, so I use that for my LSTMs.
Wealthfront is an automated investing service that saves you time. As an engineer, your time is valuable. If you want to invest, but you don't want to spend significant time evaluating your portfolio and allocating assets, take a look at Wealthfront. Go to wealthfront.com/SE Daily to open an account today and get a special offer for Software Engineering Daily listeners. $15,000 managed for free when you open your account. With traditional investment services, there are many humans in the loop that are doing things that Wealthfront automates away. When you pay the commissions and account fees of these traditional investment services, you're paying for work that could be done by a computer. So don't pay commissions and account fees. Maximize your gains with Wealthfront's Set It and Forget It investment automation. Check out wealthfront.com/SE Daily. It would support Software Engineering Daily, and it would introduce you to the world of automated investing. Wealthfront.com/SE Daily. Thanks to Wealthfront for being a continued sponsor of the show. Now let's get on with the show. So explain a little bit more how somebody sets up an RNN using Torch.
So what you want to do is you need to take the sequences of music and encode them into a text sequence, or in my case, I used UTF-8 because I had more than 128 characters I needed to encode. But once you have these sequences, you can basically dump them all onto your disk and then read them from TorchRNN. And TorchRNN will handle all the mini batching, and it'll handle all the initialization of models and training. And by the end of TorchRNN, it'll actually output a snapshot of the model, which you can then run to sample music. The vanilla TorchRNN can't. I modified TorchRNN to make it so that I could sample music and harmonize music and like all the stuff that you see on BachBot.
So we're making an effort to do more shows about machine learning on Software Engineering Daily. We did a show a while ago about Keras, which is a way to use TensorFlow or Theano in Python. And So I don't have a great feeling for how these different machine learning libraries compare. Can you explain why you chose Torch specifically? Could you have chosen Keras? Could you have used scikit-learn? Maybe disambiguate these different tools that people use.
Sure. I mean, I think that scikit-learn has a lot of it's used for a lot of kind of frequentist machine learning methods, but it's not focused particularly on building deep learning models. And so LSTMs are a deep learning model, as are deep neural networks, autoencoders, that kind of stuff. And that was the kind of model I needed to build. So that ruled scikit-learn off the table. And I actually did play around with Keras and TensorFlow a little bit before I decided on Torch. The reason why I decided on Torch was that it was actually just much faster. You still pay a slight overhead going around in Python. And also, more importantly, I found that the implementation of backpropagation through time was only compatible with Theano and not the TensorFlow backend for Keras.
Oh, well, that would be troublesome.
Yeah.
So we've kind of glossed over this. What is the salient difference between typical machine learning and deep learning?
Well, typical machine learning is, I think, a very, very broad article. And I think deep learning is a very particular subset of it. And in deep learning, you're focused on neural networks, so connectionist models, which are deep in the sense that they have many layers. And the idea is that as you get deeper into the network's supposed to learn more higher level concepts and be able to represent the information on manifolds where it's easier to make discriminative decisions.
So as these networks get deep, do they get hard to maintain for the developer?
Well, it's not really a maintenance thing as much as it is a training thing. Once these networks get really deep, like they don't even fit on a single computer anymore. I mean, I'm thinking of Microsoft Research Asia's most recent ImageNet, which was just absolutely massive.
And so they don't even care about knowing what the individual layers are doing. All they care about is, does it fulfill my task? Oh,
yeah. I mean, yeah, there's like a billion nodes in there. You couldn't even come through it if you wanted to. Yeah, a lot of deep learning, whereas the attitude kind of, at least to me, feels as if it's almost okay to sacrifice a little bit of understanding and kind of hack it around a little bit here at least and get the performance gains and maybe go understand it a little bit later.
Is this analogous to how, I did in that interview about Keras, we had a brief conversation about, thinking about machine learning versus how we think about the brain. And we talked about the idea that, like, with the human brain, you can say, look, we're just going to admit we don't know how the human brain works. We don't know the gory details of how neurons work, but we can constrain the functionality of the brain to a certain black box of functionality and have certain expectations for how that black box is going to work. And you can build entire fields like psychology and psychiatry on top of that, basically saying, we're going to take a practical approach to this. And it kind of sounds like that's how machine learning has progressed to the deep learning level, where you really just say, okay, we're not going to really care that much about whether or not we understand how these layers work, their interactions, whether we're even doing this in the most efficient way possible, as long as we get the desirable result.
Well, I mean, yeah, I agree. I think that's the attitude of deep learning. It's certainly, let's just do everything possible to solve these very complex human-level tasks with computers.
Is that why it took some time for there to be cultural acceptance in the computer science community of deep learning? I
don't know. See, I got on the deep learning train a little bit late. By the time I joined, Alex Krzyzewski had already had that ImageNet thing in 2012, and we already knew it was going to be a big deal.
I see. Okay, because I was just curious. I hear these things about, like, I think Jan LeCun, being a champion of deep learning for a long time, but not necessarily being vindicated until recently. But yeah, maybe that's for another show. So if I pull down the BachBot repository, I set it up, I run it, what happens? What do I do with it?
Well, you might want to wait a bit until after August 12th, and I turn in my thesis and clean up BachBot.
Okay.
But ideally, what you would do is you would start a Docker image or Docker container, and that would take care of all of your dependencies, and you'd just be able to run it. And if you had GPUs, you could run the CUDA Docker container, and then you run it, and it'll just process the corpus for you, train the model for you, and you'll have the model sitting there, and you can do things like BachBot sample or BachBot harmonize.
Which do what?
Which, if you do sample, it'll just generate a new chorale or maybe a couple new chorales, depending on how long you sample it. And the chorales can be kind of similar to Bach or kind of all over the place, depending on how you set the temperature. And you can also harmonize by taking some of your own text, running BachBot, like encode input or something like that, and that'll turn your music XML into the encoding that BachBot uses to go and generate harmonies for.
What is temperature?
Temperature is a parameter used while the model is running to kind of determine. So every time it predicts every time it predicts a distribution over the next note, and temperature is just kind of how much probability it's going to assign to not take the best choice.
Ah, I see. So, okay. So you have this quiz online where people can listen to samples of BachBot versus samples of Bach. And I took this quiz and I tried to identify Bach, and I only scored 60%. So are the examples with a higher temperature, are those ones harder to identify or easier to identify?
Well, that's an interesting experiment. I kind of wish I thought of that earlier, but we fixed temperature at 0.8 when we did all those samples. But what I did do is I did vary the parts that were harmonized by BachBot across the samples. So on some samples, BachBot generated the alto, tenor, and bass lines, whereas in other ones, it generated only the bass lines, whereas in other ones, it was completely unconstrained and generated everything.
Fascinating. So if I downloaded BachBot, could I train it entirely on Mozart?
You could try, yeah.
What would be difficult about that?
Well, mainly is input data. So there's 300 and something Bach chorales that I was able to use with Music XML or Music 21. I think there's about like 10 or 12 pieces by Mozart there.
So what would be so if you had a smaller data set, what would be the constraints? What would be the output of a model that was trained on less data?
If the model was trained on less data, then two things can happen. It can either overfit that data, in which case you'll just see the data that you trained on being reproduced back at you, which is not very creative or novel in a sense. The other thing that can happen is you can just learn too slowly and not learn anything that generalizes. So it's hard to pay attention to what is actually significant and what is noise until you see a lot more of the style you're trying to emulate.
Interesting. So how did you give me an idea of how you managed this project? What was your workflow for architecting and building BachBot?
Yeah, so I used Click to make a command line interface, and I did that just so I didn't have to remember what all the scripts did. Click lets you just kind of document your scripts using doc strings and your arguments using help lines. And so like every time I needed to make a feature, I would just add a new either submodule or a particular command into my Click and then implement it down there. And yeah.
Okay. So talking more about the research associated with BachBot, you uploaded several papers to the BachBot GitHub repository, and it gives some ideas about what you were thinking about when you were building BachBot. There's all these papers on, I was kind of surprised by how many people have worked with the cross-section of machine learning and music One of these was a pair of CMU researchers who also did music composition with LSTMs back in 2014. How did these different projects that use LSTMs to study music composition, what are the insights that they have found?
So the first time LSTMs were, I think, rigorously studied were by Schmidhuber and Eck back in 2002 on blues music. And, and their representation was very, very, very constrained. Sorry, I just wrote my related work section today. Sorry, what was the question?
Well, I was just curious about how people have used LSTMs to study music composition.
Traditionally, the models that have come out, they tend to actually have structure that is quite constrained to like the particular musical task at hand. So in like Schmidhuber and Eck's model back in 2002, as well as in many models that we've seen recently, there's they have models that operate at different units, such as at the chord level versus at the note level. And I mean, Bach Bot's architecture is a little bit different in the sense that we didn't do any hand engineering of model architecture. We just kind of gave it chorale music and hoped that it would learn that kind of stuff.
So there have been other projects in academia about algorithmically generating music, may or may not using LSTMs. What are some other strategies that people use to algorithmically generate music?
Well, there's the whole symbolic AI camp that I haven't talked about. Over there, you have ideas of rule-based systems, such as a grammar for describing music. You can go out and enumerate all the chord progressions that exist and all the inversions of chords that exist, and you could certainly write some rules that are applied over and over and over to kind of fractally generate motifs that appear and phrases that are all of regular intervals and such.
Yeah, and what are the other prior works that have inspired BachBot? What are the other things that are at the intersection of machine learning and or maybe just about machine learning or just about music that have inspired BachBot?
Well, I think what really got me interested in doing BachBot was the idea of just sequence modeling. A lot of the research literature in LSTMs, I think, is the most interesting research out there. You see LSTMs watching sequences of frames in a video and outputting a caption in text. It's also kind of dominating the state of the art in both machine translation as well as in language modeling, which is used in speech recognition.
Right. This is the, I did a show about TensorFlow a while ago, and one of the first things we talked about was sequence-to-sequence modeling, which is this very general aspect of machine learning. Maybe you could briefly explain what sequence-to-sequence modeling is.
Sequence-to-sequence modeling is when you have a sequence that you take as input to your model, and you'd like to produce a sequence as another sequence as an output. And the two sequences can be a variable length, and they can be of different types. Like one of them could be like, predictions 0 or 1, and the other could be real numbers. So it's a very, very general framework for just handling these types of problems. And when most deep learning people say sequence-to-sequence models, they usually mean recursive neural networks or recurrent neural networks.
So let's talk a little bit more generally. Popular music has this really catchy notion of a hook. Like most popular music songs have some kind of hook, especially the more recent songs. And if there were any aspect of music that were worth automating, it might be hook generation. Mm-hmm. What are the aspects of a musical hook that make it hard to automate?
The aspects of a musical hook? Well, we don't remember all the hooks that aren't good, so I don't know. The only hooks that I remembered have been very, very just catchy and short and can be repeated. And actually, pop music is very, very formulaic in the sense that the hook is usually repeated 2 or 3 times and then transposed up to a 5th and then played again there. But Yeah, I think melody generation is the hardest task that we've actually found for BachBot. When we tell it to generate soprano lines, people can easily distinguish that was computer generated. So I do think that is a problem that remains to be solved.
Is it something about the melodic hook that where like a hook of one song just tends to be very orthogonal to the hook of any other song, so it makes it hard to find any specific trends from hook to hook?
Yeah, that's interesting. Yeah, I mean, there are some hooks that I can think of which are very, very distinct and stick out in my memory, but I mean, there are also others which kind of played on earlier songs and varied them a little bit.
Yeah. I mean, it's just when I think about, like, I on Spotify, the playlist I listen to the most is this thing called Today's Top Hits, which is basically like the top 50 songs, globally aggregated. It's like super poppy music. And if you listen to it, there are trends that are extremely replicated throughout 20 or 30 songs in the playlist at any given time. But what seems to be very unique about at least 90% of the songs is that the hooks do seem very orthogonal to one another. So BachBot is all in piano, all of the songs that it generates, all the songs that it consumes. What would be the complexities involved in adding other instruments?
Completely trivial. I mean, BachBot actually models music just in MIDI, so you can actually throw any kind of instrument you'd like on top of it. I mean, I just happened to render it in piano because it was the most pleasant sounding in the web browser.
Okay. What is the output? So it's being output in MIDI. Is it being consumed by some MIDI player program, or what is that instrument?
So it's actually it's output in music XML. It's kind of like MIDI, except you can store markup like fermatas, which are important for determining phrase structure in Bach. But the music XML, I just run a program called MScore. It's kind of like Sibelius. It's used for just scoring music on the computer. And you can actually also use it as a MIDI synthesizer. But you can also use Fluid Synth. There's a lot of ways to generate waveforms out of MIDI.
So what are you working on now with BachBot?
Well, I have a bunch of data that it generated thanks to everyone who participated. I'm working on analyzing it, making a bunch of pretty plots and trying to discern some meaning out of it, and hopefully getting my thesis submitted this Friday.
Sorry, is that the quiz data that you're talking about?
Yeah. I mean, the quiz data is one major component of my thesis.
I see. What are the other data that people have generated? Is that what you're referring to?
Yeah. The people have generated a bunch of data on the quizzes. I mean, just the demographics of the people who participated are fascinating. Like, I think about 20% of people are advanced or expert level musicians. And the study has, hit all, or I think 6 out of 7 continents. Just kind of the scale of this operation has been massive.
So what kinds of insights have you gotten? So just to refresh people's memory, the quiz consists of listen to some songs, try to detect if they were made by Bach or if they were made by BachBot. So what kinds of statistics are you seeing in these results?
Well, I think we found that as you become more experienced in music, you're better able to distinguish Bach from BachBot, as expected. Some more interesting results is we actually found that when we generate all of the parts, so an original BachBot composition is more likely to be confused for Bach than a harmonization of one of Bach's existing compositions.
Okay, can you explain that in more detail?
Yeah, sure. So it's like when you go in the BachBot quiz, certain questions, the two parts sound about the same with some minor variation. In other questions, the two choices just sound completely different. And that's because some of the questions were harmonizing a fixed melody for Bach, and in other questions, we're completely generating our own scores. And we found that these completely generated scores are actually more convincingly Bach than the ones where we harmonize existing Bach.
Okay. So how much of your career do you want to spend researching the intersection of computers and music?
I don't know. This has been a totally new field to me. I actually have never really played with music data prior to this research project, but it's a lot of fun. I really like being able to consume the data that I model. So I used to work in computer vision, and yeah, I see myself here for, I don't know, however long until I get bored.
Cool. So what do you plan to do after you finish your research? Are you going to go work for a company? Are you going to start a company? Do you have any plans yet?
Well, so I finished my research here at Cambridge this Friday, and I'll be heading to a PhD program right after.
Cool. Well, Feynman, it's been a pleasure talking to you. I'm very interested to see where BachBot goes in the future.
Oh, yeah, no, pleasure talking to you as well, Jeff.
Thanks to Symfano for sponsoring Software Engineering Daily. Symfano is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symfano.com/sedaily. That's symphono.com/sedaily. Thanks again, Symfano.
Wow.